Our lesson goal for today is to be able to solve two-step equations and multi-step equations. Here are some steps that will guide you in solving equations. Since in this lesson we're only dealing with equations where the variables are either on the left-hand side or the right-hand side, we have an additional step, and this is step 0, apply the symmetric property when needed. Step number 1, clear out all denominators and decimals. Step number 2, simplify the left-hand side and or right-hand side. Step number 3 is a step that we will not need in this particular lesson, but in future lessons you will. Step number 4, eliminate constants from the left-hand side by addition or subtraction. And step number 5, divide each side by the coefficient. Inverse operations. Inverse operations undoes the operation. To undo multiplication, we'll divide. To undo division, we'll multiply. To undo subtraction, we'll add. And to undo addition, we will subtract. I'm going to show you where we want to get to. We won't get to this in this lesson or even the next lesson, but I just want to show you that we know how to do most of these steps already. Step number 0 will not be needed since we have variables on both sides. Since we do not have any denominators nor decimals, step number 1 is not needed as well. Step number 2 says to simplify the left-hand side and the right-hand side. On the left-hand side, we'll distribute, leaving us with 8x plus 16. And on the right-hand side, we will combine our like terms. 2x plus 4x is 6x. Step number 2 is complete. Step number 3, we won't be using in this particular lesson, but in this particular problem, you'll see that we'll eliminate the variable on the right-hand side by subtracting 6x from both sides. 8x minus 6x is 2x. So we'll bring down the 16. 6x minus 6x, they'll cancel each other out, and we'll bring down the 24. Step number 3 is complete. Step number 4, we'll eliminate the constants from the left-hand side by adding or subtracting. In this case, since it's plus 16, we'll subtract 16 from both sides. And this will leave me with 2x is equal to 8. And our final step would be to divide both sides by 2, the coefficient of x. The 2's will cancel, leaving us with x is equal to 4. By the end of this lesson, we'll be able to solve two-step equations, multi-step equations, and some real-life problems. Our essential question is, how does order operation help us in solving equations? Let's take a look at this one. Now notice that we have the variable on the right-hand side. This is when we want to use the symmetric property. So step number 0 is complete. Since we have no fractions or decimals, step number 2 is complete. Step number 3, we won't be using that, so that's complete. So now we're straight to step number 4. Eliminate constants from the left-hand side by adding or subtracting. Since this is a plus 9, we'll subtract 9 from both sides, leaving us with 5x is equal to 15. Step number 4 is complete, and step number 5 will just divide both sides by the coefficient of x, which is 5. The 5's will cancel, x is equal to 3. Let's take a look at the next example. We'll use the symmetric property. Step number 0 is complete. Since there's no denominators or decimals, step number 1 is complete. Since the left-hand side and the right-hand side are completely simplified, step number 2 is complete. Step number 3 we won't be working with. And we're back to step number 4. Notice that we're skipping 1, 2, and 3 in these cases, and we're going straight to step number 4. We'll eliminate the constants from the left-hand side, this time by adding 12 to both sides, since there's a minus 12. So we have to undo that subtraction by adding. This will leave us on the left-hand side 8n, and on the right-hand side we'll have 40. Now we'll just have to divide by the coefficient of n, which is 8. The 8 will cancel, n is equal to 5. Before we start the next problem, I want to go over equivalent expressions. When we see the expression 3/4 n, this is the same as 3n over 4. When we see 1/4 n, this is the same as n divided by 4. Remember, division is the same as multiplying by the reciprocal. Therefore, when we see n divided by 4, it's the same thing as saying 1/4 times n. What we want to not do is write our fractions like this. Sometimes, I believe like a long time ago when we didn't have the software to write it as a fraction, a lot of people would just put the slash mark. But when you see this 1/4 and this n next to this 4, this actually does not mean n divided by 4. It actually means 1 over 4n. If you want to use the slash mark, you will have to use parentheses. By using the parentheses, this will give you what you may have wanted to achieve. Let's take a look at this next example. Since the variable's on the right side, we'll have to use the symmetric property. We're going to skip down to step number 4. To undo addition, we're going to subtract 2 from both sides. This will leave me with x over 5 is equal to 10. Step number 4 is complete. Step number 5 says to divide each side by the coefficient. In this case, technically you're not dividing. 1/5 x is equal to x over 5. We could actually divide by 1/5, but it's a lot easier to just multiply by the reciprocal. In this case, we will multiply both sides by 5. The 5's will cancel on the left-hand side, leaving us with x, and on the right-hand side, 10 times 5 is 50. This is not the method I prefer to use, and this is not the method I would like you to use. It works great on these particular problems, but later on, it's going to be a bit more challenging to solve it this way. Let's take a look at a different approach. Step number 0, again, we'll use that symmetric property, but now we'll actually clear out the denominator. To undo the division of 5, we'll multiply each term by 5. The 5's will cancel here, leaving us with x. 5 times 2 is 10, and 5 times 12 is 60. Now we're on to step number 4. We'll subtract 10 from both sides, giving us x is equal to 50. And we won't have to divide by the coefficient since the coefficient is 1. Let's try the same method on the next problem. Here we wouldn't have to use the symmetric property since the variable is already on the left-hand side. We'll clear out our denominator in this case by multiplying through by 4. The 4's will cancel, leaving us with x. 4 times 12 is 48, so that's going to be x minus 48 is equal to 4 times 28, which is 112. Now we're back to step number 4. We'll eliminate that constant of this minus 48. What will undo a minus 48 would be adding 48 to both sides. Step number 4 is complete, and we won't have to do step number 5 since the coefficient is 1. The previous problems we worked on are considered 2 steps. This one will be considered a multi-step. Step number 0, symmetric property. We won't have to deal with step number 1 since we have no fractions or decimals, but now we'll have to deal with step number 2. Simplify the left-hand side and on the right-hand side. On the left-hand side, we can see that we can combine our like terms. 4x minus x, remember 4x minus 1x. Since you don't have a coefficient, it's understood to be a 1. So in this case, it's going to be 4x minus 1x is 3x. So we have 3x plus 9 is equal to 24. Now we're on to step number 4. We'll eliminate our constant from the left-hand side by subtracting 9 from both sides. This will give us 3x is equal to 15. Now we just have to divide both sides by our coefficient. The 3's will cancel. X is equal to 5. Our next example. We don't have to use a symmetric property since the variable is on the left-hand side. Step number 1 is completed since we have no fractions or decimals. Step number 2, we have to simplify the left-hand side or the right-hand side. In this particular case, we'll have to distribute. This will give us 8x minus 4 is equal to 12. Now we're on step number 4, and that's eliminating the constant from the left-hand side. Since we have a minus 4, we'll add 4 to both sides, giving us 8x is equal to 16. Divide both sides by 8. The 8's will cancel, leaving us with x is equal to 2. Let's take a look at the first of 2 word problem. You have $5 and buy 6 apples, and now you have $2 left. How much was each apple if the cost of each apple was the same? When we're writing this down, we had $5, we're minusing 6 apples, this gives us 2. But we're really not subtracting 6 apples, we're actually subtracting the cost of 6 apples. Therefore, we'll see 5 minus 6c is equal to 2, where c is the cost of each apple. Now, we'll just have to subtract 5 from both sides. This will leave us with negative 6c is equal to negative 3. Divide both sides by negative 6. The negative 6's will cancel, leaving us with c on the left-hand side and on the right-hand side. Negative 3 over negative 6. The negatives cancel, and 3 over 6 can be reduced to 1/2. 1/2 in this case can be written as 50 cents or 50 cents, but we can't use the dollar sign and the cent sign. In this next problem, I would like to go over the word consecutive first. Consecutive, following one after the other in order. An example of this is we had 4 consecutive days of rain. In numbers, consecutive would mean 2 and 3 possibly, 27, 28, 93, and 94. Notice these numbers come right after the other in either direction. We go, if we're counting up, 2, then 3. If we're counting down, 3, then 2. Even consecutive numbers would be 2 and 4. Another example might be 28 and 30, 94 and 96. For odd consecutive numbers, that would be like 3 and 5, 27, 29, and 93 and 95. In this one, they don't only want us to find the integers, but they want us to write an equation that can be used to solve this problem. The first thing, whenever we're dealing with a word problem, on our last one, we actually didn't really define the variable when we set the course, but it's great to just write it all out and define the variable and say let x equal the first integer, then x plus 1 is equal to the second integer, since we know consecutive integers increase by 1 each time. When we had 2, we added 1 to 2, we would get 3. If it was 27, we added 1 to 27, we would get 28. Our equation now, since we're dealing with the sum, we're adding the x and we're adding the x plus 1, and that has to equal 95. We can combine our like terms, and now we have our equation. 2x plus 1 is equal to 95. And now we can solve this. Subtract 1 from each side. This gives us 2x is equal to 94. Divide both sides by the coefficient of x, which is 2. The 2's will cancel, giving us x is equal to 47. 47 is not an answer. They wanted us to find the integers with an s, meaning we have more than one. X is equal to the first one. We have to add 1 to x to get the second one, which will give us 48. The answer is 47 and 48. Hope you enjoyed this lesson, and I'll see you in the next one. Bye-bye.